All right. Hello, everyone. I hope everyone is healthy and had a very nice Thanksgiving. Happy Thanksgiving, belated. Uh, Today, we are talking about the alpha release of our OPT software. And I'm Alex Kurzhansky, a research engineer at UC Berkeley PATH, and together with me today are Gabriel Gomez, a research engineer, and Servet Lapadarja. He is a PhD student at UC Berkeley Civil Engineering. And we, the three of us, are going to do each our share of the presentation. So let me our agenda today is to remind those who are not aware of what the OPT project was about. Then we'll talk about what the alpha version contains. Then we go to hands-on kind of demonstrations and how things work. And then what remains to be done between the alpha release and the product release that's supposed to happen in January. So we will discuss that and then answer questions. Despite the fact that Q&A is set to be last, please feel free to pose your questions at each stage, and I will, if I do not forget, I will stop, and also Gabriel, if he doesn't forget, and Servet, if he doesn't forget, will stop after each of the sections and ask questions if you have any. All right. So OPT stands for Operations Planning Toolbox, and it was intended as a easy to use traffic simulator for people who do planning, operations planning, and operations in Caltrans. And the objective was to make, like I said, an easy to use tool so that people do not have to learn it, spend a lot of time on mastering, but can quickly jumpstart and use it to solve their problems that they have, like I said, in planning and operations planning. The idea was to replace the simulator called FreeQ that has been used by Caltrans for many years. When I say replace, I mean provide an alternative, because FreeQ is no longer supported or further developed, and it has its flaws. OPT could potentially become a replacement and provide an avenue for feature development that are right now. FreeQ is in such a state that it is hard to add features. OPT would be a clean project where new issues could be investigated, such as managed lanes and different types of controls, etc., different types of vehicles, and so on. So, what OPT is not, it's not a very heavy commercial scale simulator such as Aimson or Visim. It does not, I mean, its interface is much simpler. It doesn't have all the graphics, 3D animations, etc. So we were aiming at simulations that would provide quick assessment of particular freeway networks. So to date, what we have developed was the software that contains the mesoscopic simulation with multiple vehicle types. It has lane changing model between the general purpose and managed lanes. It has straightforward, as we think, editor for road network and lane parameters and traffic flow parameters. And you can have more than one freeway there. So it's not restricted to just linear freeway like it like 3Q is, you can do interchanges potentially. So in the inputs, you specify demand. At origin links, by origin links, usually are meant on-ramps, and sometimes if it is open-ended from the upstream, the mainline link. On the end, in the output, you specify what flows go to off-ramps or what portions of the mainline flow go to off-ramps. In ramp metering, there are fixed rate and alinea algorithms, and the user can specify schedules when to turn on and off the ramp metering. In the managed lanes, you can specify policies and also schedules when to turn something on and off. Reporting happens on the network level, on the route level, and road section level. And each of those reports can be exported to Excel. So downloaded this to download the software. Here is the link. The presentation is actually on the web, and this presentation is on the web. The link is provided. The link is provided in the email that I sent, responding to Diane's email. And so let's go. Right now, here in the presentation that you will find on the web, all the demos that we'll have today live are recorded in the videos. And right now, let's see. Servet.
Should I start sharing my screen? All right. All right, everyone. So in the first part of our demonstration, we are going to show results which will be at the scenario level, link level, route level, and we're going to export them to an Excel spreadsheet. So we are going to start by loading our network, which you will find on the website. And this one here. And of course, you can see as well like the configuration of the network, like the on-ramps and the off-ramps, and this like the second freeway, which is connected to the first freeway by this off-ramp here and this on-ramp here. So first, we're going to start and run the simulation, just by clicking Run Simulation. And once the simulation is done, we can see that at the scenario level, which is this one, at the summary, we have the total VMT in the network. And for the two commodities that we have, which are, in this case, we are using cars and trucks, we have the total DHT in our network and how much it accounts for the origins and for the non-origin sections, and as well as the total delay. On top of that, if we click the aggregates, we can see time series for our network, and specifically, we can see the network VMT for every 5 minutes. The network VHT so moving on and see the corresponding plots. Also,
turn off your video because your voice is staggering. Okay.
All right. Do you hear me better now?
Yes.
All right. Thank you very much. So moving on, we can see also the corresponding plots at the link level, and specifically, we have a time series plot for the speed at the selected link. We have the observed flow on that link, and the number of vehicles that we have at that link for every time step. At the aggregates, as again, we can see the VMT per 5 minutes, the VHT per 5 minutes, and the delay. Well, at this section here, we do not have congestion, so we will not observe delay. But let's go to a section where we have delay. We can see here the delay, and of course, we can create routes at OPT. And specifically, if we go to the configuration here, we can click from which section we would like our route. For example, from this one until this one, and we can change the route, and of course we will obtain the corresponding reports. So just take the entire thing here, and if we go to the report, we have a speed contour plot, and obviously we can see here that the bottleneck is located right here, and how much the queue length, and we have also some other plots, contour plots, which show us the flow and the density on our lanes. And as previously, as it was on the route and the link level, we have for the specific route that we selected, we have the VMT every 5 minutes and the VHT every 5 minutes, and of course the delay. The good thing about OPT is that also we do not limit ourselves into just observing this, but we can also export the results into an Excel. So, for example, going to here, we can export the results for our route that we created. You see here. So let's open this. And all the information that we had previously for the route that was visualized, we have it also at an Excel. So the VMT, how is the VMT? So the VMT, the track VMT, the total VMT, the cars, and also we have here for the speed contours, the speeds that were generate the speed contour, as well as the density and the flow. And the same goes as well for the the same goes as well for the link. We can export for the links, as well as for the entire scenario. So every information that we see here is available, and we can specifically click on them. For example, on the link that we selected, and we have here the speed, the flow, the number of vehicles, VMT, and etc., and all the performance metrics that someone needs in order to make some evaluation. So basically, this is the first part of this demonstration, where we showed how we can obtain these results for the link, route, and the scenario level, and how we can export them at a spreadsheet at Excel.
Servet, I'm going to interrupt you there for a second.
Yes, please.
We have a couple questions, so we'll just address these quickly. So from Maurice, briefly, how is the VMT calculated? Also, can the VMT be automatically summed up to hourly, daily, annual? So, well, one, we are going to prepare a document with all of the algorithms and all of the calculations that are done, and we'll include that in the document. But just to answer your question, VMT is calculated as the flow through a link times the length of the link, that for 5 minutes, so for example, is the vehicle miles traveled for that link over that time. And then if it's a route, then we can add it up over the route. And if it's the network, we can add it up for the whole network. Can it be calculated, summed up automatically? Well, there are a couple ways to do that. One is to export it to Excel and then sum it up in Excel sort of manually. But if you wanted to do it automatically, there's a file with user settings, and right now the summation period is set to 5 minutes, but it can be changed as a user setting. So it can be summed up to hourly or daily. Actually, daily would show up in the pie chart that we have at the beginning for the whole network. Now, annually, we're only doing 1 day at a time. So annually would have to be external, that's for sure. And then the second question is, can you explain the concept of routes? A route is just a sequence of segments. So I think this will become more clear in the second demo that Servet is going to do, where he constructs a scenario from scratch. And a scenario consists of these segments that are similar to FreeQ segments. So a route is just a sequence of segments.
Gabriel, this is Tarek, if I may, really quickly, because I believe there are some new people. I see Rod Otto on there, who probably wasn't with us in the previous ones, in the previous meetings. I'm not sure that we have time to give them all the background, but maybe you want to say which freeway that is and how you constructed it and where you got the demands from before the simulation really quickly, so they don't think this is a hypothetical route.
This presentation is going sort of purposely from end to beginning, so yes, Servet is going to talk about all of that.
I have a question.
Okay.
Yes, please.
Can you hear me?
Yes.
Before getting the results from for the simulations, how do you really calibrate the model before you output your performance measure?
Well, as we know, calibration is an iterative process. So first, if we have a section which has congestion, of course, we cannot obtain exactly the demand because like the observed flow is lower than the demand. So we go at the section which is upstream, where there is no congestion, and we are going to extract the demand there. And then we will obtain from PEMS, everything becomes from PEMS, we will obtain from PEMS this kind of demand, and we will go on the corresponding on-ramps and off-ramps, and we will see the observed flows and the observed flows from the detectors that they have. So when we do that, we will start running first like by what we have observed, and we will be able to see if we replicate the present day conditions. If we do not replicate, then we start tweaking by a little bit in order to calibrate properly the demands, perhaps the on-ramp and the off-ramp demands, and also the capacity of the bottleneck that we have.
We have a section on calibration, a tutorial on calibration that I would refer you to. But this is the big question. You're asking the big question is, how do you calibrate these models? And so I think Servet, at the end, I'll direct you to the tutorials, and Servet has prepared a tutorial on calibration.
Okay. Yeah, because I believe it's essential to calibrate the model so it reflects real world condition before you output performance measures.
Absolutely. Yeah.
Thank you.
Does anyone else have any other question?
How to now build the network, etc.
All right, so we go to the second part, which is going to be, we are going to build this network live right now. So I'm just going to close this, and I'm going to reopen it.
Servet, let's start by what network are you modeling?
We are modeling right now a section of the US 101, which is at Santa Rosa, and we frankly I obtained the flows there from PEMS. I do not remember exactly the date where everything I obtained it.
Okay.
And can do this like as I'm now. So first we start by creating a new project, and we can click here and we can set the name. Let's call it, for our case, US 101. And we can set any description and the duration of that project. So in this case, I'm gonna make the duration, which is going to be about 14 hours. And we can set how many vehicle types we would like. So we can have cars, and so practically we can name them, for example, LOVs, low occupancy vehicles, and HOVs. And we can even add more, as many as we want. But for the sake of this presentation, we are going to use 2. So then we can start editing our road section. So we click on the first section here, and we click here to set the name. So that's going to be from the 5th Street to westbound 12 off-ramp. And the length of this section is about 0.11 miles. And we can set how many managed lanes and general purpose lanes we have. So here I'm going to put 0 managed lanes, and we're going to have 3 general purpose lanes. And the capacity, we can change at any value that we want. Here I'm setting it at 1,600 vehicles per hour, the free flow speed at 65, and the jump density to be at 170.
And Servet, you may mention here that you have in the settings, you can have the default values that you.
Oh, sure.
If you're not satisfied with the default, you can reset them in the settings.
Yes, that's right. You can we can also make our own default values. That's right. So now we can click and add an off-ramp. So here we just click add off-ramp, and we can select if it's an inner or outer off-ramp, but in this case we have an outer off-ramp. We select the length and the number of general purpose lanes. And as we see, the off-ramp was automatically generated here. And we can also edit the number of general purpose lanes, if it has a managed lane or not, and the corresponding parameters from the fundamental diagram. So then we go to create our next section downstream, which is going to be 3rd Street on-ramp, and this is going to have 0.3. Here we select copy from the current section in order to obtain the parameters that we set for the previous section, for the one on the 5th Street, or we can use the default settings as Alex mentioned previously, the ones that we have set. So for this case, I'm going to use the previous settings that I used. So as we see, we created a new section which has the settings that I said before: the capacity, free flow speed, and jump density. We continue by making the next section, which is going to be eastbound 12 and westbound 12 on-ramp, and this is as well 0.3 miles. And in this case, we are going to add here an on-ramp, and this on-ramp has no managed lane and 1 general purpose lane. And we see right here that we created that.
And Servet, click on the
Yes.
scenario. Click on the scenario so that you can people can see what comes out when you edit several sections. What sort of network comes out?
Oh, sure. Every time that we add, we have the sections here. So, for example, the first one, we click here and it redirects us to our first section. We can click on the third one, the last one that we made, and it will redirect us here. So this is like a very good navigation, especially when the network is pretty big. So we can click at any section and we can be redirected there and be able like to edit the lane properties or anything else that we would like to edit about that section. The other one will be Bakers Avenue off-ramp, and this one will be 0.37. In this case here, we are going to have 4 general purpose lanes, and we are going to add an on-ramp, which in this case is going to have 2 general purpose lanes. And we can see it's also displayed here, the 2 general purpose lanes of that on-ramp. Then we can go, excuse me 1 second. And we are going to add as well an off-ramp. And finally, we will go here. On-ramp, and it's going to have 0.17. So now that we have set the network for our first freeway, practically we can go and start inputting our traffic demand on the main line. So we go here and we said for our case we're going to use a demand update period of 60 minutes, and we can simply copy and paste our values from a spreadsheet as I copied it, and just do Control-V and paste them here. So it's pretty easy. So because through PEMS we can extract similarly CSV files, and we can use them directly in order to input our demand on our freeway. So we input it here, the demand on the main line. Then we go on our off-ramp. In this case, I'm gonna use split ratios for this. So we're gonna set the split ratio for LOVs and HOVs. And again, just by simply copying.
Yes. I have a question.
Sure.
What's LOV?
Low occupancy. It's
Is it a general purpose lane?
Can you repeat one more time, sir?
It's LOV, the general purpose lane.
No, it's a type of vehicle. We made our vehicles to have 2 types: low occupancy vehicles and high occupancy vehicles, just for the sake to have multiple commodities. You can have even trucks. You can set any type of vehicle in the simulation.
So this is a vehicle which type for either the managed lane or the mixed flow lane.
Right now, we are presenting one type of lanes, general purpose lanes. In the next part, Gabriel is going to present the managed lanes and what we do with managed lanes.
Okay.
Yeah. The lingo is SOV, by the way.
SOV.
Single occupant vehicles.
Yeah.
Okay.
Thank you very much. So we are adding also as well on the traffic demand on our on-ramps, again, just by simply copy and pasting the values from a spreadsheet.
And what you need to mention here, Servet, is that granularity.
The
changes every 60
we set our demand update period at 60 minutes. For example, if I make this 5 minutes, the granularity, as you can see, changes like 0, 5 minutes, 10, 15. So you can set the granularity at any value that you want. Finally, these off-ramps here. And again, we set this 60. As we mentioned earlier, at OPT, first of all, here we can see the first freeway and all the segments, so you can click at any of them. But going back to what I was about to say, at OPT, we have the capability to make also a second freeway which is connected on our first one. And this can be done just by simply selecting either an on-ramp or an off-ramp. So in our case, we are going to use this on-ramp, and we are going to click Add Section. I'm going to call this Freeway 2. So it creates a connector. And then we click again Add Section from the connector, and I can call this Freeway 2 Start. As you can see here, now the second freeway was created, and it has an off-ramp which sends traffic practically to the first freeway, and is connected with, they're connected through these blue segments here. And let me add another one downstream of it, so it's going to be Freeway 2 and. So on the second freeway, as I mentioned earlier, we create an off-ramp, and on that off-ramp, we are going to add the flows. In this case, if you recall before, we inputted the flows with split ratios, but at OPT, we have also the ability to input our flows using off-ramp flows. So I just click off-ramp flows, set my demand period, the granularity, and I can go here and just by simply copy and pasting the values from a spreadsheet, I can input them here. And
Servet explained that here you have total flow, and by type of vehicle, you have percentages of the total flow for the particular vehicle type.
Sure, thank you, Alex. Yeah, so for example, in this case, we have at this time 1,400 vehicles per hour, where 95% of them are going to be singular occupancy vehicles, and 5% are going to be heavy occupancy vehicles. Thank you for adding that, Alex. And also, at the end, we can create a new route. I'm going to call this test route, and we can select from where we would like to start our route. For example, in this case, from the 5th Street. So I just click 5th Street, and which is going to be my destination. So I'm just going to select the last section, for example, on my first freeway, which is the Bakers Avenue on-ramp. So as we see here, we have here our route, and we can of course select any section. I can just select this one or just this one. We are not limited, and when we run the simulation, we are going to obtain Give me 1 second. Oops. All right.
Yes, the reason why you have route,
Right.
not just a network, the reason why you have route, not just a network, is because if you have multiple freeways and you want to look at linear segments from point to point so that you can have contour plots, that's what networks are for. And even for a linear network, you can have one route that spans the whole freeway, and you can have also shorter segments of the freeway as your routes, just to investigate what happens on those shorter segments.
Yeah, that's right. So in general, that was a simple demonstration of how we can make by ourselves a network at OPT, and then analyze. And of course, we can go at every section, as I mentioned earlier, and then we can obtain our performance metrics for links, routes, and as well the scenario. So now I'm gonna pass it to Gabriel, which he's going to talk about HOV lanes and HOT policies.
Okay, thank you, Servet. That was great. if there's somebody with the not muted, I'm getting a little bit of feedback. So Diane asked, can we use connect sections to add a parallel collector with ramps from and back onto the freeway? So the answer is yes. This is what Servets did in his example, and I'm going to share my screen now. Let's see, share. Okay, so this is what Servet ended up with. And you see here, we have 2 freeway segments. And what this is showing is this blue off-ramp is in fact connected to this blue on-ramp for this freeway. So the demand from this section, a part of it is going to exit this off-ramp and enter this on-ramp. If we had the reason we did it this way, that they're not, you don't see them as physically connected, is because we can create any number of connections between freeways and any number of freeways. And so it would be very, very complicated to find a way of, sort of subway mapping that in. But this is the simple solution, is just color coding. So if you added another ramp and another connector, it would have a different color. And so that's how you can identify what is connected to what. And if you added more freeways, they just appear as more rows underneath. And so there's really no limit to how many freeways and how many connectors you can make.
Great. So my question was specifically about a collector with a ramp from the freeway and back onto the freeway. I understand what you're doing here, but that's useful. We can do that.
Yes, I mean, Gabriel, if you want to show it, you can. You can just create another off-ramp on the second freeway.
From let's say this is the main freeway, and let's say, for example, I put an off-ramp here. So let's say I add an off-ramp, and so now this is the off-ramp that I've just added. And then let's say over here, there's an on-ramp.
Yeah.
Okay, and so now this is the on-ramp that I've added, and now this, or I could have used this off-ramp as well. So now here's my on-ramp to the collector, and if I'm understanding what you mean by that, and so I go to the on-ramp, and I add a section upstream, and that section upstream of the on-ramp will be the connector section. So here I could give it any name I want, and so that's the connector. And now I have to connect that connector up to the off-ramp.
Connect.
And I just say connect, and I choose which off-ramp I'm connecting to. So let's just choose this one. And if I go here, I see that this is now color-coded with green. It connects to this one, and then this is vehicles are on this side freeway, and then they can exit and come back here.
Great, thanks. That was what I was asking.
Yes, and in this case, and this is also to add that this creates alternate route. So potentially, if you start from point A on the main freeway, you can go to from point A to point B, which is in the end of that first freeway.
Right.
Routes.
I can come here and I can create a new route, and I can say, I'm going to go from one to the other, but I'm going to use the connector.
Yeah.
Anyway, somehow you can make the alternate route that is going to come here, and you can evaluate the delays on either route. But we'll have more instructions on that. I think we're running a little bit short on time, and I wanted to get to questions and answers. But the topic that we're going to address now is managed lanes. And this is a fairly new part, and it's pretty, it's a little bit more complex than the rest. Because it involves lane changing, and it involves managed lanes, and it involves policies prohibiting certain vehicle types from using the managed lanes, and it also involves tolls. So there are several topics here. So I'm going to start with what Servette had. And if we go up here at the scenario level, this is the configuration panel at the scenario level. We go to the vehicle types, and you'll recall that Servette had two vehicle types. One was cars and one was trucks. Let's say I have no use for trucks anymore, and I'm just going to call these HOV. Actually, he had called them LOV instead of cars, but I'm going to, okay. Now we have two vehicle types, cars or SOVs and HOV vehicle types. And if I go now to the segments, the name of the traffic. So now we have HOV and car here, and this is the data that Servette had entered. But let's say I know that the percentage of HOVs is actually larger than 5%. I want to make it 30%. So I can I can do that manually by entering the numbers here, or I can use Servette's trick, which is copy paste from Excel. And so now I've changed the percentage of HOVs to 30%. And I will do that across all of the ramps. Okay, this is an off ramp. Off ramp has 8% of cars leaving on this off ramp and 8% of HOVs leaving of this off ramp, and that is relative to the number of cars and the number of HOVs. So I'm going to leave that as is. If I go to this ramp, I'll do the same. This on-ramp, this is the on-ramp that is connected upstream to the connector. So it does not have any demand on it, so I don't have to change it. I go to this off-ramp. Again, off-ramp, this is defined with split ratios, so I don't need to change it. Now, this is the off-ramp that was defined differently. And I think if you weren't here for one of our previous demonstrations, you might not know this, but see, this checkbox here tells us that there are two ways of defining how many vehicles get off on an off-ramp. One is to provide the percentage, the absolute percentage, and that's what I did here. Okay, so here the checkbox is not checked, and it's saying that of all vehicles, of all cars, 13% are leaving during the first hour of the simulation. Okay, here we have checked the checkbox, and what that tells us is that we're providing the absolute number of vehicles that are leaving, which is in this case 1,400. So it's not provided as a percentage, but as an absolute value. And of this 1,400, 95% are cars and 5% are HOVs. Okay, so these are two alternative ways of specifying the off-ramp flows. And the reason we want this is because this is the data that we actually get from PEMS. We get absolute flows from PEMS. So that's what we enter there. And here I'm going to put the 70%, that of that 70% are cars and 70% are HOVs, because that's what's representative of the whole population of vehicles. Okay. And then finally, there was this traffic demand on the second freeway. And I also want that to be 70% and 30%. Okay, so now I have changed the demand picture so that it is 70% SOVs and 70% HOVs, and I can run that again. And I will get, so this is a 14-hour simulation. I get a contour plot, which is similar to before. But still, we are dealing with just as a uniform general purpose facility. What we want to do is create convert one of the lanes into a managed lane and see how that is going to change the behavior. So how do we do that? I'm going to convert of this freeway, the leftmost lane into a managed lane. So I'm going to start at the upstreammost part. And what I do is I go to the lanes and I add a managed lane and subtract a general purpose lane. And then I go that way down the freeway, adding and subtracting, and so forth. And now I'm done. I've converted the leftmost lane to a managed lane, and I can run that again. I have not yet specified the policy which says that cars or SOVs cannot use the managed lane. But now I'm going to get results segregated by general purpose lane and managed lane. So I have that in the contour plots, and I also have it in all of the time series plots. I have time series for general purpose. I have time series for managed lane. And in each one of those, it's going to tell me what is, for example, the flow of cars, the flows of HOV vehicles, and the total flow. And so all of my results are now doubled, or I have for managed and general purpose. Now the next thing I want to do is add a policy. So I go here again. I'm at the scenario level, and we're going to look at this next tab, which is lane management, and that's where I'm going to say that one, cars are banned from using the HOV lane, while HOV vehicles can use it for free. Okay, so now I'm going to kick out all of the cars. I'm going to do that beginning in this, like at hour 2 of the simulation. Okay, so now I have a schedule which is for the first 2 hours. The managed lane is open for all. From the second hour to the end, it's restricted. Cars are banned. But actually, I would like to open it again for cars after let's say 10 hours. So at the 10th hour, it's going to be open for all again. And so now I have a schedule with 3 entries, right? Open for all, restricted, then open for all again. And now I simulate this.
Oh, sorry, and Gabriel, and you double click on each of these entries and edit. Basically, you will edit the times, etc.
That's right. That's right. So now look at what has happened. Something terrible. I kicked all the cars out of the HOV lane, and I noticed that there's a huge bottleneck that creates a disaster. And that, if I look at the configuration, is because there's this 2-lane bottleneck here that is creating a huge pileup. And so my final thing that I want to investigate and demonstrate here is, okay, it was a bad idea to throw out all of the cars. Let's allow them to use the managed lane, but we're going to toll them. And so that, again, is I go to my policy, and I'm going to double click. And instead of banning the cars, I'm going to toll them. And how am I going to toll them? There's a tab here that I'm going to enter a table, and I have the data for my table is right here. So I copy this data, and I'm going to paste it in here. And what this says is that for if the flow in the general purpose lane is low, then it costs very little to join the managed lane. And so this is a flow to price a table. And then there's some other parameters here that we'll explain later. This actually I have to change for it to work correctly. And what vehicle types are okay? So it's that. Basically, I'm going to allow cars to use the managed lane, but they have to pay. So let's simulate that again. And finally, now, I should have shown before that there were no cars in the managed lane. This red line had dropped to 0 between 2 and 10. This red line, the flow of cars had gone to 0 in the managed lane. But now we see that many cars are actually opting to pay because they can save a lot of time. And so we see a significant number of cars in the managed lane. And if we look at the contour plots, well, it has substantially improved the congestion because lots of cars are opting to use the managed lane to sort of circumvent that bottleneck. So that this is the kind of thing you can do. You can then go to the totals, the scenario level, and look at how the VHT has changed, how the VMT has changed, and so forth. So we only have 5 minutes left, and so I think it's a good time. Well, let me just mention here.
We actually have till 2:30.
Oh, we do.
Yes, but go ahead. Yeah, it would be
Okay,
good to.
okay. Great. So we have a little bit of time, but I'm going to switch over to the slides. Somehow this is. Oh boy. This is not working. View. Okay. Okay, so here, that is where we are in terms of hot lane modeling. I mean, there's a lot more there to explain all of the details of the parameters and how to calibrate it. But that we're going to include all of that detail in our documentation. And of course, if you have any questions, we're very happy to address those. So, but from now until our sort of the end of the project, there are several tasks that are remaining. On the modeling side, we want to improve the lane selection model. That is, how do vehicles choose when they join the managed lane, and make it maybe a little bit easier to calibrate and have intuitive parameters for that. We want to implement events. So right now, you can't say that there's an accident or that there's a lane closure or a ramp closure. And so these are events that in the next version, you'll be able to set events in the UI. Then we want to report on emissions. And this will have to do with connecting the software with MFAC emissions calculator. On the UI side, well, we're going to, provide windows for editing events. We're going to report on emissions. Even though, the user interface may seem a little complicated, but it's actually, we're really happy with it. It's once you start using it and you get it, it's very simple to use, and you can construct pretty complex freeway networks very quickly, as you saw with Servet. And so we're really happy with that. But I think we can make it even easier to use with populating more of this right-hand panel, which we didn't show, and also more context help. And also any suggestions that you guys have, this is really helpful because we've built this, based on our own desires and thinking, but any way that it can be made better to address the things that you guys do is very helpful. We're going to improve the installation so that it works on all different operating systems, and any other improvements that you may request. On the documentation, well, there is already a lot of documentation on the website. There are tutorials and videos and so forth, so you can have a look at that. But what is still not there is the documentation of all of the algorithm, all of the simulation math that goes on behind the scenes. So we're going to completely, reveal all of this so that people can know what's going on. And also about how to calibrate the model. Servet has also already created some of this, but there are additional parameters like these lane change parameters that it's not clear how we'd be selecting them. So we're going to document that. Next thing. Okay, so for some reason this isn't working. I have to go one by one. Okay, so these are sort of all parts of our website. There is a tab for a user manual that includes a glossary of terms defining, lots of the things like route and scenario, the terms that are OPT terms. And then there are a series of video demonstrations that you can look at. Then there's a section of the website called tutorials, which have PDF files, sort of step-by-step tutorials for building models and calibrating models. And then there's a section for Q&A. So if you have any questions, this is where you could contact us and we would post answers, and this is where the conversation happens. So it's great that we have more time, because we can open it up now for Q&A and comments, requests, and so forth.
You may want to answer the question that's on the chat first.
Okay, let me look at the chat. Okay, so I'm going up. How does OPT handle on-ramp flows entering a congested section? How does on-ramp flows affect mainline flows in a congested section? How does OPT handle an off-ramp that backs up into mainline through lanes? Do you enter demands or volumes observed into OPT? Does OPT evaluate weaving? And if so, OPT use weaving results to adjust throughput? Okay, all very good questions about the dynamics of the underlying macroscopic model. So the first, how do we handle on-ramp flows entering a congested section? I'm a little bit concerned about going into these details, but the gist of it is that it's the cell transmission model. So the congested section cannot accommodate all of the flow coming in. So it will say, I can only accommodate, say, 20% of the flow coming in. And so then only 20% of the flow comes in and 80% stays back. And that propagates the congestion back into the on-ramp. And then now if we have mainline and on-ramp, then how do these share the limited resource of space in the downstream section? So it depends. So if you have an auxiliary lane, so we didn't talk about auxiliary lanes, but if you have an auxiliary lane, then they don't share it. The on-ramp gets the auxiliary lane and the main line gets the general purpose lane. And then then the mixing happens through lane changing from the auxiliary lane into the general purpose lane. If there is no auxiliary lane, then there is a splitting of the available space amongst the on-ramp and the main line. And that happens according to a rule that is part of the internals of the thing, and that will be in the documentation. How does OPT handle an off-ramp that backs up into mainline through lanes? Okay, very good question. So again, it depends on whether that off-ramp is coming from an auxiliary lane or coming straight from the general purpose lane. In any case, it will only congest those lanes from which it is connected. So it might congest the auxiliary lane, or it might congest the general purpose lane, but it can never connect. If it's a right-hand off-ramp, it can never congest the managed lane directly. It can congest the managed lane indirectly through lane changing. But on the other hand, if it's a left-hand, an inner off-ramp, then it could congest the managed lane directly, but not the auxiliary lane. So it depends on. So there's a separation, a real separation of lanes. Do you enter demands or volumes? So we enter demands into OPT. That means that if there is a congestion that goes over the sensor from which you have extracted the demands, then there is something that you have to do in order to adjust that in the entry of data. But from the perspective of OPT, you are entering demands. Does OPT evaluate weaving? And if so, OPT use weaving results to adjust throughput. Okay. Weaving is, so in FreeQ, weaving was a checkbox that would adjust the capacity according to the lane changing that was happening. But it was an adjustment of capacity. In OPT, we have an explicit model of lane changing, that the vehicles that are changing lanes are occupying space in the adjacent lane. And so they're creating these sort of bubbles that you'd actually see in real traffic. So it's not that we've sort of arbitrarily changed the capacity, but there's a lane changing model that includes weaving. So you don't have to turn it on or turn it off. It's always there. Yes, we do. I'd say we model lane changing, for which this weaving reduction in capacity is sort of an emergent phenomenon. How do we deal with HOT? Okay, I think we've covered that. There seems to be a lag. Okay, it works fine for me. Is there a limit to the number of separate freeways? No. Mac 2, yes. In the next, so if you have a Mac, you can download now. You can get the jar file and you can run it. But we are going. I think Alex can address that as well. How we're going to deal with Macs.
So right now we can create a jar. So if you do have a Mac, we will create a jar file for your download, so that you can just download the jar file and click on it, and it will run. Right now we have only exe installer that runs on Windows, but yes. So right now this is a temporary solution for this alpha release. But for the for the product release, we will do a proper installer that would include license, or like it is open source license, that you can use it, that you use it at your own risk, etc., etc. All these wordings, and and so that you can run. Right now, if you need, we'll make you a jar file and put it on the web. It will be on the web for you to download.
So the videos don't have audio, I believe.
Captions. You need to turn on captions.
You need to turn on captions.
Let me add on that. There's some videos that have audio and there's some videos that have captions.
Okay. Curtis asks, can multiple sections of roadway be selected at the same time to speed up editing? That's a great idea, but it's not possible right now. Can a collection of sections be copied and then later edited, for example, to change one main line from SO? So yeah, that would have really sped up this creating of the managed lane. Right now, it's all section by section. Suggest on-ramp icon be a yellow merge sign, not yield. Okay, we'll take that into account. I think you said this is going to be free to anyone, not just Caltrans. Well, this is all open source code. So yes, it's available to anyone. You can find different. Oh, this is from Servet. Okay. You can find different playlists of tutorials at this link. Oh, neat. Okay, so it's organized into playlists. Great.
Yeah, the video. We try to make the videos short, so that you do not get bored. They're about maybe from 2 to 4 minutes each. So yeah.
So we have really, you know, we're pretty proud of this product that we've made, and that Alex and I at least have been in this for quite a while, since Topol, putting together sort of simulation software, and so this reflects our history and our sort of understanding of how to do these things. But now I think it's really your guys' turn to tell us what we don't know and how we can improve the product from now until January. So there are probably many things that we can improve. So
Gabriel, I have a question. Seems like this software or this app is for static analysis, and I understand that you have to input demand from the demands are from PAMs, and the data from PAM not most, it's always are serve volumes, not the actual volume. It's constrained volumes, but the true demands are not provided from PAM. So how do you deal with that? Like, say you have a bottleneck and you have a queue, on the main line, and how do you capture the queue volume?
Yeah. So let me just quickly, Alex, that
Okay.
It's not that you have to enter things from PEMS. We are not, like, OPT is agnostic to where the data comes from. So it may come from a very sophisticated sort of demand model that you have, and so you may have other sensors that are recording demand for that situation. But there's no restriction, or there's no rule in OPT saying that you need to get it from PEMS.
Yes, the data can come from any manual counts. The data can come from demand model. The data can come from you are responsible for the data. The reason why in our demos we used PEMS, it was just because it was the easiest source to get the data from. That's about it. But you are right. For instance, anywhere where you measure, you do not measure the demand. You measure only that goes through. What goes through?
Yeah, that's right. That's only the constraint demand, not the actual demand.
Exactly.
Yeah. And so you have to somehow use your own judgment what you put, assuming that here the simulator treats the data that you input as a demand. You need to use the measurement data wisely, understanding that it may not be the demand, it may be just flows.
This is Tarek. If I may just add one thing, I think, Diane, you have another contract with Cambridge, I believe, that discusses the differences between the types of models and when to use which one.
Yes, I do.
Because this is a 3-4 hour discussion, the difference between demand and flow, and how to have a macroscopic model use demand as opposed to flow. That's not a 5-10 minute discussion, in my opinion.
And that's right. And Mark, we can talk about this at length, and we can have some training. So, and there will need to be more of these webinars, and possibly a few one-on-one training sessions for OPT. And Alex, I don't know if you need any more testers. I think you do.
Yes, we do. We'd like to. And in the course of the development, we tried to establish one-on-one connections, and with few people it was possible, but mostly this was district was it district 5? Yeah. But if you're willing to jump on the bandwagon, test it, provide some feedback, suggestions. So suggestions must be. So we accept any suggestions, but some of them will be able to implement within the scope of this project. Some of them may be larger than that. For example, things such as copy-paste links that already created so that you can create exact copy. It is a good suggestion, but it would be hard to implement within the scope of this project, primarily because there are a lot of caveats, such as if you copy-paste a link, how is it going to be connected and to what? So, and those kinds of things. So it may be, it may sound easy, but it's not conceptually very easy even just to grasp how these things would work. This is one of the reasons why things of today work one by one. Some other things could be copy paste. You could use copy paste, such as you can copy paste demands and split ratios from one on ramp or off ramp to another. Now, as Diane said, we are looking for volunteers to test it. And with those who are going to test it, our suggestion is to test it on their own projects and see if we can consult and use, because there are subtleties, and we may have suggestions how to model certain scenarios inside OPT. Those that involve managed lanes, those that involve specific discussions on demands versus volumes, and also those that may involve collectors and alternative routes.
And I think Diane mentioned that in her emails, there is an EA, a charge number for these testers, right, Diane?
Yeah, we have a certain amount to provide charge codes for testers. So this is not totally volunteer. We just need the approval of your supervisor.
Yeah, so you can what do they call it? Kill two rabbits with one stone if you do your own project and also test the software.
Aside from the suggestions on UI, I really want to encourage that if you are running a situation, a scenario, and you get a result that doesn't look right, in terms of, the vehicles, the flows are not right. Those are really, really important to us, because we want to leave this project with a really solid model underneath. That's the most important thing to us, I think. So we do want to collect scenarios and focus on those where we can improve the results.
Yes.
Diane, we need to really look at the demand that we are inputting into the model, because that really affects the VMT and the VHT.
Well, Mark, this is part of the calibration process, and any demand or volumes can be input into the model. So it's a matter of you calibrating, and that's something
I understand that, Diane. What I'm saying is the demand that you put into the model will affect the VMT at the end.
Yeah.
Absolutely. Yeah.
So we really have to look at what demand we should be inputting into the model. Is it a constrained demand, or the total demand, or the served demand? You know what I mean?
Yeah, and that's true of any simulation. It's part of the calibration process.
And my response to you would be, what do you use if you use FreeQ?
Can you say that again?
Which demand do you use when you use FreeQ?
Actually, I really haven't used FreeQ. I've been dealing with micro simulation.
Okay, same question. Which demands do you use when you do microsim?
That's the same question I've been having, even with the micro simulation. And we haven't really have a good solution to this.
Yeah. So like I mentioned earlier, this is a 3-hour discussion. I mean, there is no right answer. I think District 4 had that triangle, and I don't know if Rod Auto is still on there, where they could estimate the real demand based on the triangle that Albert T had, the methodology had developed a few years ago, or a few decades ago now. But if you look at the travel demand model, for instance, you can see links that have demand to capacity of 2. And I'm as skeptical about those as saying that flow equals demand. So I'm not sure the industry has reached an ultimate solution for that. But I don't know if Rod is still on. I mean, there are ways to estimate it. I just don't know which ones are perfectly accurate.
Yeah, that's my question. My ultimate question is that what's the right appropriate way to estimate that?
Mark, and this is a really good question, and also because it depends. It could be a different answer depending on the model that you're working with, because what you want to ask is, what does the model do with the demand that can't enter the network if there's congestion, right? And so if the model is just throwing those vehicles away, that's one thing. But if it's keeping them for, like, putting them in later, that's a different thing. So it may determine, which demand you use.
And
Yeah, that's what that's what one thing I'm looking at what you guys are coming up with. It's a static analysis, but with micro simulation, it's those are dynamic analysis, which is
No. It's I don't know what you mean by static, but it's not static.
And by the way, microsim is not necessarily what we're trying to replace.
What I'm saying is, like, for micro simulation, like, say Vism wise.
Yes.
And it's changing the volume, and the model is changing as time changes, and it takes more volume into the model, because when you run like a couple hours, it will like when you run the model, and it frees up the more capacity, and it will absorb more
that's what we do.
queued volumes.
Yes.
Mark, this is what we are doing. So if your demand cannot be serviced, it is being stored in the queue. But if later your freeway frees up, then this queue is serviced. That's how it works. So in our simulation, we do not discard. Gabriel is exactly right. It depends on how you treat the demand that you cannot service. And in our case, we do not discard those vehicles. We store them in a queue. If by the end of the simulation you did not service, you will still see that you have unserviced queues.
Okay.
This is Ray. How do you know how many there are in the queue at the end of the simulation? I mean, how many you have not served?
So we know because you specify the demand that wants to go. For instance, you have an owner, right? And you specified 10,000 vehicles per hour, but the capacity of the owner is only 2,000. So every hour you will accumulate 8,000 vehicles. So in the end of the simulation, you will see the queue that sums up these extra 8,000 vehicles.
And one thing that should be noted is for OPT, capacity is an input, which it is not for microsimulation.
Yes.
That is very important. Can I just say to the previous question, there's a trick for that, which is that you use a cooldown period in which you, like at the end of the simulation, you turn off all of the demands and you let these queues empty out. And then for that cooldown period, you measure how much VMT went through, and that's what was left at the end.
In free queue, we are assuming that at the beginning and end of simulation, there is no queue, there is no congestion. So that to get the best correct results. So I am assuming that's the same thing here.
Well, it is your responsibility as a modeler to provide that. Here, like Diane said, you can put any data in. In the beginning, you start with empty freeway. There is no congestion. That is true. In the end, however, depends on what your demand was. If you have this cool down period, the one that Gabriel just mentioned, you will end up in free flow and all the queues will be flushed. But if you don't, and you can end simulation in the middle of the day, just in the middle of the congestion. In that case, you will have congestion in all the queues. But it's your responsibility.
Yeah, but true, Alex. But you can always choose the beginning time and end time where you know there is no congestion. And
Yes.
I think that's the practice in FreeQ. So FreeQ doesn't start at 4 p.m. and end at 5 p.m. because in a congested direction, because that would never work. It would never be no congestion before and no congestion after. So it's by selecting the right beginning and end times, you get to the same answer or the same approach like you use for FreeQ.
That's correct. So here you specify the start time and duration of the simulation. So your start time can be 0, means 0 hours, and the duration can be 24. So it means you run the simulation from 0 hours to 24 to 0 hours next day. Or you can run your simulation just for 2 hours between 8 and 10. It's up to you. But when you run it for just 2 hours from 8 to 10, it's your responsibility. You need to understand what sort of data you put in. And understand that by 10 o'clock, your congestion may not be solved yet.
Correct.
Let me just give us a situation where this may become it could be an issue that we haven't talked about events, and FreeQ doesn't do events. But what if you had an accident that is, you said you thought that by 6 p.m. it was going to be, no congestion. That was what it was in your calibration scenario. But now you put in an accident and it created a lot of congestion. So it's you have large queues still at 6 p.m. And then the question arises, okay, how do I know, how many vehicles didn't even make it into the network at 6 p.m.? Then you have to think about this cool down period strategy. But we'll get to that with events.
That's right.
I believe you have 3 more minutes or thereabouts. So
just to reiterate what Gabriel said, we invite you to start testing with your projects. Then in that case, we can spend much more time with you individually, discuss how you deal with this, how we suggest, or we can we can have this discussion on a more detailed basis. Because right now I hear that there is an interest in that. And today, the purpose of today's presentation was to present a simulation tool. And I see that those people who do run simulations, they are interested in what sort of in the data. And the data is an important question. This project, however, was not addressing the data issue per se. However, Gabriel and I are quite experienced because we dealt with lots of real freeway simulations and corridor simulations, and even CSMPs with Tarek. So we do have some knowledge, and we can have a discussion. Maybe we can suggest something that you would find useful. So,
and vice versa.
All right. Did we go through the list of questions in the chat, Gabriel?
Yeah, I think we're up to date on the chat.
Okay, and any more questions, comments?
So how are we going to go through the process of identifying the testers? Do you want to give a certain time for people who are interested to talk to their supervisors? Or how do you want to do it, Diane?
Yeah, why don't you, I would urge people who are interested to talk to their supervisors this week and get back to me, and I can set up charge codes. We want to encourage people to do more than a few hours. We don't want you just to look at it and bill a couple of hours. We want people who are serious about doing a project with OPT. So if you have a project, that would be ideal.
Yes.
Don't really interested, you can talk to us about it.
Yes. If you have a project, like I said, we will go an extra mile and just really engage and help you and see what we can do. Or show you the tricks, because sometimes it's not obvious how to do things in OPT right away if you have a complicated scenario like with alternative routes, etc. But there are ways, and these scenarios would also be interesting for us and maybe beneficial for you, for advanced users, for advanced modelers. Yeah. So please contact Diane, and also if you obtain the charge code, write to us. Don't hesitate. We will put the jar file on the web so that people who are Mac users can also run the software, not just the Windows people. And we stand ready. Wait for your enthusiasm. Okay.
Okay, and if anyone has any questions, feel free to contact me, and I'll forward them.
Yes. You can always do it by emailing to Diane, who forwards emails to us, or submit the questions on the website in the Q&A section. Yeah.
Do you want to give them the URL one more time?
It is all in the presentation that I responded to your email, Diane, earlier today. It has the presentation and it has the slide with all the links.
Okay.
But if you come to the website, which is opt.ucbtrans.org, which is also in the presentation, you will see everything is clear where to go to Q&A. The website is pretty self-explanatory. And where you find tutorial materials and some documentation. Like Servet mentioned, there are lessons on calibration. They talk a little bit about data, maybe not to the extent we want, but we would like to hear from you more specifically so that we can address your questions more specifically. And here in the chat, Gabriel put the link to the Q&A section on the website.
Thanks everyone.
Thank you very much for participating.
Thank you, everybody.
All right, I will stop recording now.
Thank you. Nice job. Appreciate the presentation.
Thank you.
Very much. All right.
Bye-bye.
Have a good one. Bye-bye.